Hello, everyone, and welcome back to the fourth and final day of the 2021 NASA Earth Science Applications Week. Over the past week, we've learned so much from researchers and end users on the many ways NASA Earth Science helps make our world a better place, while also celebrating the official 20th anniversary of the NASA Applied Sciences program. Thank you all so much who are joining us from across the globe. My name is Ryan Hammock. I'm a fellow with the NASA Developed National Program based out of our Tempe, Arizona location, and I'll be your MC for our Promoting Health and Air Quality plenary session. For a brief summary, we will kick off today with plenary sessions from 12 p.m. to 2 p.m. Eastern Time on Zoom, the same link you've used to join us today. Following the daily plenary sessions, we will have a networking social with the broader developed community on a platform called Wonder. Please join us starting at 2 p.m. for this networking event with current and former participants, leads, fellows, advisors, and partners. For the complete agenda of today's events, please visit the event webpage. Additionally, in case you miss any of our events, all the talks from today and earlier this week have or will be recorded and will be posted online in the coming days. All events from this week can be joined directly from your browser, and all links are available on the event webpage. Given the number of attendees, speakers, and events we have occurring this week, we would like to thank you in advance for your patience with any technical difficulties we may encounter. A few housekeeping items before we begin today's plenary session. Everyone is automatically muted, so we hope you'll use the chat function for any comments you may have and direct questions to our speakers in the Q&A section. And now, without further ado, it's my pleasure to introduce Lawrence Friedl, NASA's Applied Sciences Director, to share some opening remarks.
Great, thank you, Ryan, so much. And really just going to take a couple minutes here so we can get to the real things and the real people who are going to be speaking. So first of all, I've been so pleased with this week. Thanks to everyone who has made it such a rich one. On Monday, in my opening remarks, I encouraged us to listen to the range of organizations that we're working with, as well as the fleet of NASA satellites and other data that are looking back at the Earth, as well as how we work and some of the projects we support. And I would say across the range of presentations and flash talks and others that we've been doing just that. To give you some stats for this year's Earth Science Applications Week, we have crossed the threshold, the benchmark there, the milestone that we had of 1,000 registrants. And so we are over 1,000 registrants, which really was a goal. And this is from over 65 countries. And so it's really great to just showcase globally all the value that NASA and other forms of Earth science have to the world. On Monday, we had over 260 attendees. Tuesday was about 250, and yesterday was about 220. And on each day, we're drawing people from over 2 dozen countries. And so just again, fantastic reach. As Ryan alluded to, we're going to start today looking at some activities from our application areas and capacity building program area, specifically looking at health and air quality issues. And then later on, we're going to have a chance to showcase a range of other activities that we have going on, both within the Applied Sciences program and with NASA more broadly. And a real highlight this afternoon is going to be hearing from my boss's boss, who is Thomas Zurbuchen, who heads all of science at NASA. And so with that, let me wrap up. I'll turn it back to Ryan so we can get going with health and air quality.
Great, thank you for those opening remarks, Lawrence. Now we'll get started with our presentations today, and we'll start with John Haynes, our Program Manager for Health and Air Quality Applications, on an overview of the NASA Health and Air Quality Program.
Well, thanks so much, Ryan. And again, thanks, Lawrence, for that great introduction, and for all of you for joining with us today for the Health and Air Quality plenary session. As Program Manager of Health and Air Quality Applications, I wanted to briefly give you an idea of our mission, highlight a couple of projects, and then, of course, I'm going to turn it over to our amazing slate of speakers for this hour. So let's go to the next slide. So Health and Air Quality Applications has 4 facets to our mission. We support the use of Earth observations in air quality management and public health, particularly regarding infectious disease and environmental health issues. We also promote the use of Earth observing data and models regarding the implementation of air quality standards, policies, and regulations for economic and human welfare. We address issues of toxic and pathogenic exposure and health-related hazards, as well as addressing the effects of climate change on public health and air quality to support managers and policymakers in their planning and preparations in the years and decades to come. We have over 30 projects currently in our portfolio, the largest it's ever been in the 20-year history of applied sciences. And I've listed some of the major partners on this slide, but it is far from exhaustive. But just to give you the idea of the breadth of our program, all the way from the state and federal level to the international level, along with working with the private sector. So I'm going to highlight 2 projects in this opening remarks today that I hope you find of particular interest. So let's go to the next slide. We'll start with this project. It's a project concentrating on Saharan dust in the Eastern Caribbean. It's led by Dr. Pablo Mendez Lazaro of the University of Puerto Rico in San Juan. I had the pleasure of visiting with Pablo and his team in San Juan on my last trip for NASA pre-pandemic in January 2020. And to be honest, when I arrived in Puerto Rico, I wasn't sure what to expect, as he and his team had been through so much adversity. First, Hurricanes Irma and Maria struck the island in 2017, inflicting almost $100 billion in damage and devastating the island's infrastructure. That was followed by a series of strong earthquakes in December 2019 that has continued to this day. And little did anyone know then in January 2020 that a global pandemic unseen in over a century was just on the horizon. But through it all, Pablo and his team have persevered. Beginning in 2017, amid the destruction of the hurricanes, Pablo and his team started work on an early warning system for Saharan dust and air quality in the Eastern Caribbean. Saharan dust often travels across the Atlantic, and it's a natural fertilizer for plants and coral, but the dust, especially in large quantities, causes poor visibility and air quality. It affects human health by causing irritation of the eyes, nose, and throat, and often contains fine particulates and other minerals that are of a size which easily infiltrate and irritate lung tissue. Vulnerable populations, such as children, the elderly, and people with asthma and other pre-existing conditions can be adversely affected. So early warning can give people time to prepare. Project partners include the Puerto Rico Department of Health, the National Weather Service San Juan, and the Environmental Protection Agency. In setting up the system, Pablo's team installed on-the-ground air monitors, replacing many destroyed by Hurricane Maria. And they also analyzed aerosol data from Earth-observing satellites and sensors, such as MODIS and VIIRS. Much of this work had to be done at home on generator power, as some teams' members' university offices did not have electricity for over a year after Hurricane Maria struck. Pablo and his team was able to get the early warning system up and running in June 2020, and it was just in time. Later that month, the most severe Saharan dust storm in 50 years impacted Puerto Rico. It was known as the Godzilla dust storm. Thanks to this new system, federal and state agencies, as well as medical doctors, were given 3 days notice of the storm's arrival, which gave them time to notify the public and safeguard vulnerable populations. Additionally, in the midst of this global pandemic, the team is now examining if exposure to African dust has significant impacts on health and mortality associated with COVID-19. And we can go on to the next slide now, please, Ryan. Speaking of COVID-19, I wanted to mention this project under the tutelage of Dr. Ben Zajcik of Johns Hopkins University. And it showcases the power of the global community as seen through the Group on Earth Observations Community of Practice for Health, which is my honor to be chaired by myself at NASA along with a colleague at NOAA. Dr. Zajcik's original project was using satellite observations of temperature, soil moisture, and precipitation to understand global rates of gastrointestinal illnesses. However, once the global pandemic began in March 2020, Dr. Zajcik was able to leverage the power of the GeoHealth community of practice and all of its global partners in order to expand this project to investigate potential environmental factors that may influence COVID-19 transmission. Of course, leveraging the immense expertise and power of the COVID-19 Dashboard and Resource Center at Johns Hopkins University. I invite you to visit the GeoHealth Community Practice website at the bottom of the screen to learn more about this community, and everyone's welcome to join. It is open to everybody across the world, and we still, in the midst of this pandemic, are meeting every 2 weeks discussing this topic along with many other topics of Earth observations and how they can be used for societal benefit in health and air quality applications. And with that, I'm going to wrap up. I hope you are as excited as I am about this amazing slate of speakers we're about to hear, to give you just a taste of the power of the use of Earth observations and helping tackling the challenges facing the globe in health and air quality. So I turn it back over to you, Ryan. Thanks so much.
Great. Thanks for that fantastic overview, John. Now we're going to hand it off to Dr. Asaf Anyaba from Goddard Space Flight Center to talk about how Earth observations are supporting global disease surveillance.
Okay, thank you very much, Ryan. So I'm Asaf Anyamba with the University Space Research Association at NASA Goddard Space Flight Center. I'm happy to be here today to report to you on our project, which is utilizing NASA Earth observations and model data to support disease surveillance worldwide. Next slide. Next slide. So as you well know, the phenology and population dynamics of many mosquito vectors is driven by climate and weather patterns. Fortunately, we have a massive amount of NASA data that we can use to determine the seasonal and annual dynamics in climate, as well as using model focus products such as NDVI from MODIS, land surface temperature from MODIS, soil moisture from the North American Land Data Simulation System, and also products from the North American Multimodal Ensemble Focus on rainfall and temperature. So these are just among the variety of many data sets that are available from NASA satellite records over the last 50 years or so that can be used to in various applications. And in this example here, I'm going to talk about for vector disease applications. Next slide. So how do we go about this? We are utilizing these massive amounts of data to build integrated machine learning models, for example, here for chikungunya, in combination with other data sets, including mosquito vector distributions, human population density, and in doing so, we are able to map and focus areas at risk for disease outbreaks, for example, chikungunya. Now, you may ask, why chikungunya? And the answer is chikungunya, like dengue and Zika, is among a host of neglected tropical diseases that have no vaccine at the moment. Looking back, the reemergence of chikungunya in the Americas in 2013 resulted in an epidemic that lasted 3 years. And I'm sure all of us can relate to that, knowing what is going on right now with COVID. Here at home, actually during that time, there was local circulation of chikungunya in Florida and Texas. So it basically informs us that these tropical diseases have also potential to attack us here at home. Next slide. So the focus of this project is providing the Department of Defense with information products for force health protection, in that when they have these products, they are able to protect our men and women wherever they are deployed overseas. And also we are contributing to public health surveillance for chikungunya with our partner, Pan American Health Organization. And this map here shows you the focus we issued recently for August 2021. Next slide. So basically these products, we provide them with a lead time of about 1 to 3 months. And currently our evaluation shows that the performance of the model is 80%, in that 80% of the locations we have focused to be at risk have reported chikungunya activity. In addition, using the massive amounts of outbreak data collected, we are able to create new products showing the baseline risk, like what you see on the screen here. So this is showing the baseline risk of occurrence of chikungunya based on historical information. This is important for Department of Defense for deployment planning, as well as, if you think about it, for the public. In order to travel somewhere, you need to know the risk situation there. So this baseline risk will provide you information regarding that. Next slide. What we also do is we monitor actively what is going on in terms of the outbreaks. So this map here shows you outbreak activity from October to present. And this is important to know if caseloads are increasing in particular combatant command, like Indo-Pacific, US CENTCOM, AFRICOM, NORTHCOM, EUCOM, or in other areas. This is important information because if you see that there is a trend towards increasing case, then that will trigger an alarm in terms of preventive measures. Next slide. So all this information is publicly available. We have built an application called ChikRisk App that is available at vbbusra.edu. Next slide. In addition to that, we are actually exploring the utilization of new measurements on soil moisture from NASA's flagship measurements of soil moisture, the Soil Moisture Active Passive Mission, or SMAP, to determine the utilization of soil moisture in VBD applications. As we very well know, soil moisture analyzes the patterns of vegetation and temperature that determine vector population dynamics. So this is going to be a critical variable going forward in building disease models. And these particular illustrations here show you examples that we have been looking at. For example, outbreak of plague in Colorado, chikungunya in Brazil, Rift Valley fever in Mauritania, and dengue in Southeast Asia in the country of Cambodia. They basically illustrate how different soil anomaly conditions can be a trigger, for example, for plague and Rift Valley fever of the emergence of these particular diseases. And on the other hand, when you look at chikungunya and dengue, the soil anomaly conditions can be amplifier of these particular diseases. Next slide. So I just wanted to kind of wrap up this section of the presentation by looking back. We are now in a very hot summer that we have not seen before. But looking back 9 years ago, in the summer of 2012, when we had similar conditions, the geographic anomaly pattern was centered on the center of the country. And during that particular period, we actually had an emergence of a large-scale outbreak emergence of West Nile virus. So as we deal with extreme heat this summer, as we are dealing with COVID resurgence, I also think that we should also take personal protective measures against vector-borne diseases. For when we protect ourselves, we also protect public health. Last slide. So to finish up, I would say that this work would not be possible without creating partnerships with various interagency partners, DOD, USDA, NOAA, as well as international organizations like PROMED, PAHO, OIE, and non-governmental organizations like EcoHealth. Also, the resources we get from the Applied Sciences Program, Health and Air Quality, are basically what you call the oil that fuels this work going forward, as well as the resources we are receiving from other NASA science missions. And also, I would not finish off by failing to recognize the many scientists and analysts at Goddard who are involved heavily in making sure this work goes ahead. Also our collaborators from USDA, NOAA, PAHO, and more importantly for Dr. Stephanie Uz, our Applied Sciences Manager at Goddard Space Flight Center, who coordinates and enables this work. So thank you very much.
Great. Thank you for that presentation, Asaf, on how Earth observations can support disease surveillance. Next, we're going to pass it off to Dr. Julia Golke from Virginia Tech for this flash talk.
Great. Thank you, Ryan. So this project is a collaboration between my group here at Virginia Tech, Ben Zaitchik's group at Johns Hopkins University, and Samar Swartz's group at University of Virginia. And much of the results I will present today were completed by Balaji Ramesh, a master's student in the geography department here at Virginia Tech. So next slide. Next slide. Our project started out with the overarching question of how can EO data be used to really better prepare and respond to adverse health outcomes during and after flooding events. We're working with CDC, Geospatial Research Analysis and Services Program, or GRASP for short, and Houston Health Department is also, we're also working with them on this project. Houston and the surrounding area serves as the case study due to the amount of flooding experienced recently, particularly with Hurricane Harvey in 2017 and Imelda in 2019. We're using inundation data as shown here. This product is produced by the Dartmouth Flood Observatory, and this shows the maximum extent of flooding observed during and following landfall of Hurricane Harvey in August 2017 in Southeast Texas. We further use NOAA stream gauge data to determine the duration of flooding, and then we've matched this EO data with census tract and zip code level data, healthcare visit data collected in 2017 through 2019. And then we've also examined census-based static index produced by the CDC to identify particularly vulnerable census tracts. Next slide. So these maps show how we've processed that inundation data into flooded versus non-flooded census tracts on the left-hand side in the case of Harvey, and then on the right-hand side for Imelda into zip code level flooding status. Because our health data are at the zip code level in this case. Stream gauges are used to estimate, as I mentioned, the duration of flooding, and on these maps, they're signified by the red triangles. Next slide. The Social Vulnerability Index, or SVI for short, takes 15 census variables and weights them equally to produce an index to identify areas that should be prioritized for supplies, shelters, evacuation support, or other health support. These 15 variables are broken into 4 themes: socioeconomic, household composition, race, ethnicity, and language, and then housing and transportation. You see that on the right-hand side, the 4 blocks. And these maps show the overall SVI and broken into themes for that Houston area. Next slide. So what we did is we used an interrupted time series approach to analyze all of this data, meaning that we have both a time control as well as a spatial control. And this was implemented using Poisson regression with an interaction term. So here I'm showing rate ratios produced for cause-specific health care visits during the flood period of Harvey and 1 month and 2 months following the flooding, so those post-flood periods. We see that, for example, carbon monoxide poisoning visits were up 3.2 times higher during that flood period within the flooded tracts, after, again, controlling for rates and controlled periods and non-flooded areas. So this is expected due to power outages and damage damages increasing the use of generators. Some less direct health outcomes are also noted here, so including increases in insect bites as well as pregnancy complications. We see that for most of these health outcomes, they're elevated during that flood period and the second flood, even post-flood, the flood period. And so they do come back down though to background levels after about 3 months post-flooding for this example of Harvey. Next slide. So these next set of results are shown from our analysis of Tropical Storm Imelda. As shown in the previous map, this was a less severe and less widespread flooding that was caused by this storm. And in this case, we're actually using data that was directly pulled from syndromic surveillance system of the Houston Health Department. Now, this is data is different, and these systems are used in real time, delivering essentially healthcare visit data hourly from facilities to the health department, and are really designed to provide situational awareness to improve responses to upticks in healthcare visits. So the systems use intake symptomology, so chief complaint data, to provide an immediate class of diagnoses based on text queries. And this is often, again, prior to even the physician's defined diagnostic codes. So also, as mentioned previously, this data is at a more aggregated spatial resolution, so only home zip code is provided. And here we're showing, again, these rate ratios using the same interrupted time series analysis approach, and zip codes classified as either moderately flooded or highly flooded. Again, across those 3 periods, flooded, and then the 2 post-flood periods. And what we see here is that we see similar results from the Harvey analysis, upticks, for example, in pregnancy complications and insect bites. And we also captured elevated respiratory syndrome in this analysis. And we hypothesized this possibly could be due to mold growth after flooding, which has been documented after other flooding events. Next slide. So here we're showing rate ratios again from the Harvey analysis again this time. So separated by census tract CDC SBI category. Remember, this is a defining socially vulnerable from census data. So moving from the least vulnerable in green to the highest vulnerability in yellow. So in the previous rate ratios, the rate ratio graphs that I presented, we were showing cause-specific visits that increased during within flooded areas during the flood period. Note here, we're showing results of overall emergency department visits, which actually decrease within flooded census tracts during the flood period and the first flood, post-flood period. And here we show that for the more highly vulnerable census tracts as defined by CDC SBI, we actually see less of a decrease in ED visits during the flood and first post-flood period. And we think this result could be capturing less evacuation within those more vulnerable census tracts. And in fact, broken down by theme of SBI, the next kind of 4 graphs that you see there, housing and transportation, the last theme on the right-hand side, seems to explain this overall result shown. So next slide. What we've shown is that EO data, when coupled with healthcare visit data, can be used to improve characterization of when, where, and what type of health outcomes we might expect with flooding. Our next steps include use of the synthetic population simulation that you see here in the graph that tracks daily movements of populations over census tracts. This graph is showing, for example, high correlation with static CDC SBI during the nighttime, since census data, of course, is based on home address, but less during the day due to movements. So we're also looking to use this work to further support potential incorporation of inundation data into that real-time syndromic surveillance systems to improve situational awareness at health departments. So with that, I'll end this presentation with a thank you. I really appreciate the opportunity to present our work today.
Yeah, thanks, Julia, for that fantastic presentation. Really interesting there. And next up, we're going to hear from Odette Holzinger from Groundwork Hudson Valley, and also Julia Wolenka from the NASA Develop Arizona location on how NASA Earth observations are being used to address urban heat in Yonkers, New York.
Hello, everyone, and welcome to the last day of Earth Science Applications Week. My name is Jillian Wallach. I'm the project lead for the Yonkers Urban Development Team, and I'm joined by our end partner from Groundwork Hudson Valley, Odette Holzinger. So to get started, I will let Odette take over and introduce the study area and Groundwork Hudson Valley. Next slide, please.
Thank you so much, Jillian. Pleasure to be here. Thank you all for joining this session. So my name is Odette Holzinger. I'm the Climate Resilience Manager at Groundwork Hudson Valley. Groundwork Hudson Valley is an environmental nonprofit based in Yonkers, New York. part of the Groundwork USA network, which works to promote environmental restoration throughout post-industrial mid-sized cities all over the United States. We have 3 program areas at Groundwork. One is our sustainability education, where we set up this off-the-grid science barge on the Hudson River, an educational facility for school groups and other youth groups to come in and learn about sustainable urbanism. Our youth leadership group, where we hire youth from Yonkers to work in environmental restoration projects, and the climate resilience program, where we promote local environmental restoration projects like the Yonkers Greenway, a rail trail project, and our daylighting of the Summel River in downtown Yonkers, as well as our latest project through which we were fortunate to partner with the NASA Develop program. That latest project is called Climate Safe Neighborhoods, where we analyze the vulnerability of to climate change of neighborhoods in Yonkers and promote different mitigation strategies, mainly focusing on extreme heat and flooding. Next slide, please.
So identifying locations with heat effects required a few different steps to map heat. We ended up using NASA Earth observations from the Landsat satellite series, Terra Modis Aster, and EcoStress from the International Space Station to generate surface temperature and heat maps. We use these maps to analyze vulnerability and illustrate mitigation scenarios with an urban heat and cooling model called INVEST. We used a variety of socioeconomic and environmental variables to create an overall heat risk index across the city of Yonkers. And we used a network analysis to create accessibility maps for local cooling centers. The INVEST model yielded heat maps detailing daytime and nighttime cooling capacity and heat mitigation for both current and future scenarios. Next slide, please. So the left side of this slide displays the indices used to generate overall heat risk. The darker the reddened areas, the greater the heat risk. A few focused neighborhoods detailed by Groundwork Hudson Valley are called out on the map, and they are oftentimes located within high-risk areas. Some characteristics common to these neighborhoods include high population density, high rates of renters, over 50% without college education, and over 35% foreign-born. The right side of the slide shows our proximity analysis results. The upper left shows walkability buffers over a heat exposure index to determine which areas include underserved communities. The dark blue areas signify buffers around the cooling centers, and dark red areas signify areas of that high heat exposure. While some high exposure areas overlap with the cooling center buffers, many are actually outside walking distance. The bottom right map displays the service area for each cooling center. The black lines denote the service area boundaries, and again, the red areas show high heat exposure. Each green buffer shows the proportion of each service area population that is located within the cooling center buffer. So essentially within walking distance of each of these cooling centers. And the actual proportion of the population that is within the cooling center buffer and that's within the service area for that cooling center is labeled on the map. Next slide, please. And then this slide gives an example of INVEST model outputs. The output maps on the left display the ability of areas within the city to mitigate heat effects. Red areas represent less heat mitigation, and green or blue areas represent areas of greater mitigation. The left map displays where heat relief is being provided in Yonkers, and in comparison, the right map shows the increase in relief with increased shade. If you take a look at the callouts from each map, you can notice that the left map has a darker red signifying less capacity for heat mitigation, and the callout from the map on the right shows that that red has lightened up, displaying increases in heat mitigation. The graph on the right displays hypothetical scenarios of change in albedo and shade in the focal areas designated by Groundwork Hudson Valley versus the average across the entirety of the city. As you can see, a change in the focal neighborhoods provides greater potential mitigation, and this implies that concentrating strategies in particular areas provides a greater relative improvement boost to cooling benefits. Next slide, please. I'll turn this back over to Oded.
Thank you. Thanks, Jillian. So yeah, this is a term that we use throughout our work is what we call vehicles of change. And that's where we take all this very important data and the conclusions provided to us by the analysis that the folks from NASA Develop did. And we actually try to impact ongoing projects, ongoing plans on the ground in Yonkers, mainly in Southwest Yonkers, which is the most vulnerable area. So some examples could be a major downtown redevelopment the city is planning to do over the next 10 years. And we're trying to make sure that this will include as many mitigation strategies and measures as possible. Local projects like the Yonkers Greenway Park that I mentioned before, or local neighborhood master plans. We're working with municipal and affordable housing providers, going through construction projects to add more tree planting and reflective roof painting programs, so on. And finally, the city of Yonkers is about to start developing its climate action plan. And we're also using all this data provided to us by NASA Develop to make sure that the climate action plan takes environmental justice into account, making sure that the vulnerable communities are addressed. Thank you.
Yes, thank you for joining us today, and we'd like to extend a very heartfelt thank you for all of the support we have received through this project, including to Oded.
Thank you very much.
Fantastic. Thanks, Jillian and Oded, for talking about your really great developed project. Now we're going to pass it off to Dr. Pawan Gupta to talk about air quality monitoring in Thailand.
Thanks, Ryan. Hello, everyone. Today I will talk about air quality monitoring and forecasting in Thailand. Next slide, please. So Surveyor, a NASA USAID partnership, strengthened the capacity of countries in Asia, Africa, and America to use the satellite data and geospatial technologies to address critical challenges in climate change, food security, land use, water, disaster, and air quality. So the map showing the Surveyor hubs, and in this effort, we are working with Surveyor Mekong hub in Thailand. Next slide, please. There are over 60 stations managed by the Thai Pollution Control Department to monitor the air quality in Thailand. The major pollution source in the area includes the fossil fuel burning, roadside dust, seasonal biomass burning, and transboundary pollution. The Thai agency has very limited or no capacity on forecasting. Those NASA Surveyor, in partnership with the Thai Pollution Department and the Thai Space Agency GESTA, started an air quality research and co-development efforts in 2019. Next slide. So as a result, the air quality service for Thailand is developed. This tool allows to peek into historical aerosols and fires data from MODIS, provides near real-time images of aerosols and fires from MODIS, VIIRS, and ARMS, and make prediction for future using NASA GEOS global model calibrated using local data with machine learning algorithms. So today I will focus more on the forecasting part of the tool. Next slide, please. The forecasting frameworks take data from the GEOS FP run, which includes satellite data assimilation combined with the other satellite data products, surface measurements, and feed into a machine learning algorithm to bias correct for the local conditions. The output from the machine learning algorithm is surface PM 2.5 which is then converted into an air quality index using country-specific guidelines and displayed into a web application which allow API access. The initial validation results are shown on the scatter plot on the left, shows an excellent performance between output from the machine learning algorithms and the data from the measured by the ground monitoring locations. Next slide, please. Here is an example of a case from earlier this year in February when fires were burning in neighboring countries and smoke transported to the parts of Thailand. Showing here are the viewer's true color image on the top. The red dots on the second image shows the location of fire detected by viewers. And the third image shows the smoke detected by viewers on the same day. The animation in the last image shows the PM2.5 forecasted for the next 72 hours, which are initialized on February 18 from the newly developed Air Quality Explorer tool. The 3-day forecast clearly shows the transport of smoke in Thailand and affecting air quality, including in the cities of Bangkok. Next slide, please. The data quality and transparency are very critical to build the credibility around the application. This Air Quality Explorer tool allows to see real-time forecast performance at ground monitor location as the data becomes available. The example shows such an analysis from one selected stations. The two line shows ground measurements and the forecasted field 3 days back in time shows an excellent relationship between the two. Although this is one of the selected case, it does not happen all the time. In addition to the real-time validation, we also provide air quality index calculated for 24-hour mean for the Thai Pollution Control Department to monitor air quality in the region. The forecast from the AEQ also being used in phone app developed by the university and government partnership to monitor and prescribe fires in certain parts of Thailand. Next slide, please. The Air Quality Explorer tool is launched and adopted by Thai Pollution Control Department as their official air quality forecasting back in November 2020. The picture showing in-person launch event and virtual presence by NASA and other partners. The surveyor continue to work with the tool to improve the accuracy, its resolution, expanding the domain, and to track the transboundary pollution. We have been also doing regular capacity building activities, including training among the local partners in the region. Next slide. And the last, I'd like to highlight that this effort greatly benefited from the research and development done by us through an RNA project funded under the Science of Terra, Aqua, and Sumi and PP. It's a good example where research to application transition happens. So we took the research and data developed under this project over India and scaled our approach over Thailand. And finally, I'd like to thank NASA Surveyor team and its partner in making it possible with the special thanks to Gitika for the front-end development of the application and Amanda for coordinating the projects among various partners. And I think that's all I have. Back to you, Ryan.
Great. Thank you so much for your talk, Pawan. Next, we're going to hear from Dr. Tracy Holloway from the University of Wisconsin-Madison and the NASA Health and Air Quality team for an overview of the NASA Health and Air Quality Applied Sciences team.
Thank you so much, Ryan. I cannot start my video. The host is not letting me, but now I can start it. Here we go. Well, thank you so much. It's really a pleasure to be here today and share with you the work of the NASA Health and Air Quality Applied Sciences team. We are now in the third generation of this team, which launched earlier this year and will extend for 4 years through 2025. Next slide, please. This kind of hard to say acronym we pronounce HACAST And this is a NASA-funded effort from the Applied Sciences team. We have 14 PIs, and each of the PIs have a network of co-investigators and collaborators in the United States and around the world. And our mission is to really be a bridge connecting NASA science with a wide range of user communities in public health and air quality management. So far, the cost is about $12 million, which supports 3 main types of activities. Each one of our 14 PIs proposed work when they applied to be on the HACAST team. So these proposals were peer reviewed and are moving forward with some exciting work already coming to bear fruit. There are also collaborative projects within the team. And the idea here is that a lot of real world problems don't map perfectly onto one individual's research group or one university, and really require the expertise of collaborators with experience using NASA data and working with stakeholders. We call these tiger teams, and our tiger teams were just defined earlier this year, focusing on cross-cutting problems and priority stakeholder initiatives. In addition to these 2 threads of applied research, we also have active outreach, engagement, and efforts to do rapid response when issues come up. And a lot of those initiatives are managed out of my group at the University of Wisconsin-Madison. Next steps. What we found over the past decade almost is that having a team structure for applied sciences fundamentally changes the outcomes. HACAST is just been launched in its 3rd generation, as I mentioned. The first generation was called the Air Quality Applied Sciences team, and that ran from 2011 to 2016. That really focused on air quality management in the United States. In 2016, the health was added on to clarify our relevance to public health stakeholders and expand to a global community. And just as an example of something that might fall under health but not air quality, think about all the fires and fire response. Of course, air quality is a huge part of that, but so are the direct health responses of community health organizations and fire managers. This team structure increases the visibility of this work to end users. Oftentimes people are interested in using NASA data or connecting with an expert, but they don't know where to turn. And while we all have web pages and LinkedIn pages and publications, it's not a fair burden to put on a potential user to have to sort through and figure out who's the right person for the job. HACAST has really tried to be a front door, being welcoming, engaging, and having a lot of different ways that organizations and individuals can plug in whatever their level of technical expertise or prior work with NASA data. This team structure builds a culture to promote these collaborations. We have a lot of 2-way dialogue between scientists and stakeholders. And we've had then lots of collaborations. And also when we see something that's working with one potential stakeholder or one group, then we can quickly transfer that to other organizations. So it really has led to a rapid spin up of the highest value activities. Next slide, please. I mentioned how our structure is kind of a two-stream approach with the individual members' activities that are continuing on through 2025, and these 2 rounds of Tiger teams that were just announced. Next slide. The group who composes HACAST is very diverse, coming from universities from Alaska to Florida, federal agencies, and bringing expertise from epidemiology to modeling to data analysis. Next slide, please. So I wanted to use the next couple of minutes just to give a few examples of some of the hot off the press work coming out of this team. And one study is from my colleague Chin Zhao at Texas Medical Center, and she's using NASA data on lights at night to quantify health outcomes. And I'll confess, I did not know that lights at night had direct health outcomes, but actually there's a long research showing that a variety of outcomes, including breast cancer, is exacerbated by exposure to lights at night. It blocks chemicals in the body that are needed to repair and fight cancer. So there's a paper that just came out in Environmental Health Perspectives led by Dr. Zhao, looking at how disadvantaged communities are subject to this known health risk and using NASA data to help connect the dots. Next slide. Another recent set of work comes from my colleagues at Colorado State University, where the Tiger team is led by Jeff Pierce, working with Emily Fisher and Cheryl Magsamen. And actually, Dr. Magsamen is also one of the leaders of our recently selected Tiger team. Their work has been connecting wildfire smoke with health impacts. And in fact, they did the first ever study quantifying the health impacts of long-range smoke from forest fires relative to nearer sources of pollution. And in fact, they found that wildfire smoke is especially damaging to health. This is a huge issue considering how much smoke has been covering the United States this summer. And this group has been very active in not just doing cutting edge research with NASA data, but getting the word out to the public. They've been on the news from WHYY in Philadelphia to the TV news in Colorado. And in fact, they were even on our own public radio station in my home state of Wisconsin. Next slide, please. Another hot off the press study is using NASA data to understand the links between COVID lockdown conditions over the past year and air quality. And my colleagues Susan Annenberg and Dan Goldberg at the George Washington University have been using satellite detect data on nitrogen dioxide, which we have every day all around the world, and is a unique data source because it provides spatial coverage needed to look at community scale health impacts and environmental justice. And they compared how different neighborhoods across the US changed under lockdown conditions. What they found is that the communities that have more people of color had lower air pollution during lockdown conditions. But even during lockdown conditions, that lower air pollution was still higher than in that same city's white communities, highlighting environmental justice disparities in a very compelling way. Next slide, please. Susan Annenberg at George Washington also just released a beta version of a new website providing global data on particulate matter, NO2, and ozone. And not only did she make this cool website, but she's reached out to stakeholders in public health and transportation and air quality to get their feedback. And I think this is a great example of the kind of dialogue and partnerships that really characterize HACAST. I'll also make the point that, we're only a few months into this current HACAST team, and this project reflects the investment that NASA has been making over the past years. All of the data sets that are in Dr. Annenberg's website were generated from activities under the last version of HACAST. Next slide, please. And as a final example of some of the type of work coming out of HACAST, I'll share an update from my own research group here at Wisconsin. We've been working with the EPA to understand how satellite data of formaldehyde can be used to understand health risk to air toxics. There are, I believe, 287 air toxics that are associated with cancer and neurological disease, birth defects, a wide range of negative health outcomes. But in part because there's so many of these chemicals and also because they're somewhat hard to measure, that the ground-based measurements of these air toxics are very limited. But actually, the #1 environmental air toxic associated with cancer is formaldehyde. And that is a chemical species that satellites can see. So we worked with Kirk Baker and Baron Henderson at the EPA Office of Air Quality Planning and Standards to evaluate the model that EPA uses for their toxics assessment using satellite data and exploring how different satellite data products fit into this framework. Next slide. So I'll end here and tee up a video that we've made just so that you can hear not just from me about our team, but from a few of our team members. It doesn't reflect everybody, but I hope it will give you a little taste of some of the work that we've been doing.
Hello, I'm Dr. Tracy Holloway.
Dr. Susan Annenberg.
Dr. Arlene Fiore.
Dr. Jinchu Mao.
Amber Soya.
Dr. Weizhou.
Dr. Jeff Pierce.
Dr. Yang Liu.
Dr. Pawan Gupta.
Dr. Xiao Qian. Dr. Cheryl Magsman.
Dr. Dan Goldberg.
And I'm a member of HACAST.
HACAST is the Health and Air Quality Applied Sciences team. Our collaborative interdisciplinary team of 14 PIs and a network of stakeholders applies NASA satellite data to tackle health and air quality challenges across the United States and around the world, with funding from the NASA Applied Sciences Program. We work with stakeholders to address their needs and use research to address real-world problems and opportunities to support clean air and public health.
Our project, in partnership with EPA, NOAA, and Department of States,
The Global Burden of Disease Study, the State of Global Air,
Specifically, the New York State Department of Environmental Conservation and NESCOM, the Northeast States for Coordinated Air Use Management.
At National Jewish Hospital.
This is working with the American Lung Association,
the CDC, the EPA, C40 cities, and the International Council on Clean Transportation.
We will work with the American Cancer Society
at the Rocky Mountain Institute,
and we will provide technical support to the Lancet Countdown project.
Currently, HACAST uses a wide range of NASA tools and data products to connect Earth observations with the needs of decision makers. For example,
we will be using fire detection and aerosol optical depth products from Modus, Veers, and GO16 to identify fires and associated smoke plumes. We will use these data to identify and quantify smoke and estimate health impacts on respiratory diseases like asthma and chronic obstructive pulmonary disease.
We will support the CDC to create a skin cancer dashboard for school districts and the public.
I'm working with partners at the Rocky Mountain Institute to see whether satellite data can show a signature of home heating on cold days in the United States.
We're using satellite observations of nitrogen dioxide to track NOx emissions, NO2 exposures, and NO2 attributable pediatric asthma incidents across multiple scales.
Learn more and get involved by visiting haycast.org.
That's our story, and we are sticking to it.
So I'll hand it back over to the organizers. Thank you so much.
Fantastic. Thank you so much, Tracy, for that overview and that fantastic video of HACAST. Now we're going to go back to John Haynes for some closing remarks of today's Health and Air Quality Plenary.
Well, thank you, Ryan. Thank you, Tracy. Thank you to all the speakers in our session today. I don't know how I can top that last video. That was just really amazing. All I can say for all of the past hour of talks is wow. And I hope you've just gotten a taste of how in so many facets of our lives that health is intertwined with. Everything from air quality to environmental health, to urban development, to vector-borne diseases, to even things like lights at night. And how our scientists and our stakeholders are utilizing again the power of Earth observations to help tackle these and many other challenges across our nation and our globe. So again, thanks to all of our speakers. That was a real tour de force. I so much appreciate it. So much appreciate all of the attendees' time today to hear from us. And please, in these troubled times, please stay safe. Please stay healthy. And if you are able, please get vaccinated. So hopefully in 2022 Applications Week next year, we can all meet again in person. Thank you again from me and my team.
Great. Thank you so much, John. Well, we've now reached the conclusion of the Promoting Health and Air Quality Plenary session, and we'll be transitioning into our closing plenary. As we transition, we'll now watch a video highlighting the Severe program. And to learn more about one of the scientists highlighted in the video, please check out the link posted in the chat. Additionally, while we're playing the video, please also follow the link in the chat to answer today's poll question. We would love to hear which sessions or activity was your favorite this week.
Chasing raging fires, tracking the trail of disease, monitoring water resources worldwide. It's all in a day's work for NASA Earth-observing satellites. NASA works with people around the world to solve problems in their communities with the help of Earth data. One such person, Dr. Neon Sirimongkon, a citizen scientist and professor in Thailand, who created a mobile phone app to warn her community about agricultural burning that may lead to poor air quality.
The faster we determine the location of fire, the higher chance we can put out that fire. This helps minimize the forest loss and reduces the air pollution, which has an impact on local people's lives.
For more than 5 years, NASA and USAID have been on the ground in the Mekong River Basin, working hand in hand with local agencies and organizations to address challenges from climate resilience to food security. This partnership fosters collaboration with local decision makers to identify issues their communities face and equip them with training and tools to use Earth data and find solutions. Together, the team developed the Air Quality Explorer tool, a web-based platform for tracking and forecasting air quality in Thailand and the lower Mekong River region. This tool gives the Thai Pollution Control Department the information it needs to protect people in real time.
This tool is easy access. All people can access it. And then we get more awareness from people because they see the data, technology and knowledge advance very quickly. So we are very happy to have a project with NASA and ADPC to improve our knowledge.
The Air Quality Explorer is a great example of what's possible with NASA Earth data and the type of work that the Applied Sciences program is proud to support and excited to see come to life. With this app, Thai officials can better monitor and forecast pollution hotspots, giving their citizens timely information to make better choices that could impact their health. It's really fantastic to see.
And that's just one example of what's possible with NASA Earth data. This is Earth Science in action. Learn about other NASA projects that are happening around the world at appliedsciences.nasa.gov.
What a wonderful video from our Surveyor team. Hello, everyone. My name is Adriana Lecomte, and I'm a fellow with the NASA-developed National Program for the Langley Research Center in Hampton, Virginia. I will be your MC for the closing plenary today. And to start us off, I am very excited to introduce the Associate Administrator of the Science Mission Directorate, Dr. Thomas Zerbuchen, to share some remarks.
I want to make sure, does everything work okay from your end?
Yep,
Adriana?
We hear you okay.
And all right, great. Look, I'm just so excited to be part of this session right now and to talk to you all. First of all, I wanted to thank all of you for bringing to this meeting and to the work that you're doing, the passion that drives so many of us, the passion that relates to the very words that you just talked about, science, understanding our Earth better, the universe better, is by itself an incredible activity because it moves, it talks about how, where we live, the space in which we live and the space in which we think. What's also important, of course, is that science is most relevant for our daily lives if it's focused on the Earth. The most beautiful planet we know in the whole universe, a planet that, of course, is changing, a planet that is changing, as we heard in this week's report that was released, is changing more rapidly than many of us were hoping. When I was, of course, as an undergrad, I took actually all these Earth science classes that are common to many of the degree programs that some of you are in, others used to be in. And recently I took the time and I went back and looked at predictions. And I have to tell you, unfortunately, many of these predictions were too optimistic. And so that's really That's really one of those elements that, we're learning about the Earth. The Earth that we're seeing right now with its heat input, with its ice melting, with its flooding, with severe weather, is a world that we have not explored as humans. And therefore, focusing all these science tools onto the Earth is an absolutely critical element that Earth Science, our division of Earth Science, is really the best organization in the world to do, together with our international partners and also our agencies elsewhere in the US government. I want to tell you that, of course, the third word on that you just relayed in that move, which is the word action, is very much at the heart of applied sciences. Lawrence, Friedl, and the whole team are focusing on that with the help of all of you and the ingenuity of all of you. What's the most science at its most powerful is science that not only moves forward our understanding, but creates direct utility, just like the example that we saw of Thailand. We have many examples that relate to our farming communities, our fisheries, they're, about disaster response, about many activities like that. For us, when science turns into action in a direct fashion, we all win. We win as scientists because we know that our knowledge immediately moves forward our community. But most importantly, and equally importantly, we are, in fact, addressing and affecting in a positive fashion directly the lives of our fellow citizens, of people who are around the Earth elsewhere. And I want to tell you how excited I am that you spend, of course, this entire week or large fraction thereof, but also are spending time this summer and throughout the year on those important topics. I mean, that is one of the core elements of our entire program, and perhaps the most impactful in everybody's lives here. So I just really am excited about all of you from all over the world that are doing this and are actively participating in this. If there's anything we learned in the last 16 months or so, as we all are affected by this one particular virus or the mutation that occurred the time before, is how we're all connected together. What happens in one part of the Earth affects all of us over time. We're traveling from one to the other. We breathe each other's air. For example, observing the stars anywhere in the United States outside of the West Coast is very difficult this year because of all the smoke and fires that are out there. In fact, in flights that we do here at the East Coast across the United States, we can go collect and kind of detect some of these smoke particles, and frankly, even organic parts of those kind of sweeping from the western side of the United States over here. Again, the Earth is really connected directly. And especially with COVID, we're learning that very, very deeply. And with that recognition, and with the recognition that we all share so much in common, I just want to congratulate you for the work that you do and for the impact that you create. Yes, it is Earth Science action. And action is where, if you want, the rubber hits the road. I'd like to stop here and just kind of see if there's a question or somebody wants to drive my way, Adriana, or how you want to use the time. It just to benefit interacting with the people, if that's okay with you. Go ahead.
Great, Dr. Zabukin. I'm sure we can check the chat and see if there's any questions anybody would like to ask. I can read it out and we can have you answer it.
By the way, which camera am I looking at? Am I on camera somewhere? I can't see my own camera. Is it this camera or this camera?
Right in front.
So this one?
No, the other one. The one you were looking at already. Yep.
Okay, good. Yeah, I wasn't sure. I couldn't figure. I don't see myself, so I apologize for that.
Great. I don't know if I can see anything in the chat, but I have a question for you. Given that this is Earth Science Applications Week, do you have a favorite part of NASA Earth Science or applied sciences, or something that's impressed you from this coming year, from all the work that has been done towards
so
a plan?
I tell you, the two kind of applications that I've really been fond of, and I've spent actually quite a lot of time kind of learning about, is the applications that relate to illnesses that are carried by mosquitoes and so forth, and especially the work that was done in Louisiana, here in the United States, and also a Midwestern state, which has very similarity, forgot which Dakota it was, that really has a specific set of illness, and kind of the recognition that our, global health, that was the topic of the previous session, and the health here really relates to not only what the environmental parameters are, but also how the kind of the things that are alive, whether it's mosquitoes, whether it's deer that move and so forth, how they kind of affect our own health. For me, that's just absolutely compelling, and I just love that. I think the second one that has to be at the heart of what we're doing, and I'm really convinced this is one of the most important, but also one of the most exciting, frankly, is everything we do around fires. I mean, we just saw the person in Thailand. I just want to tell you, fires have been such an important presence in in the United States as well, but around the world, and allowing us to find these things quickly and provide the information to where the decision makers are. For me, it's just a super compelling way of using applied science at Earth. Adriana, there may be a question now or two. Go ahead.
Yes, definitely. So I have a question from the chat if you have time to answer one more.
Sure.
So in this time of climate change focus, will there be more focus on climate change risk and adaptation applications within applied sciences?
It's my full expectation that applied science will be even more intrinsic and more connected part of all of Earth science. As Earth science is growing, so will applied science. So the answer absolutely to that is yes. So that's a very simple answer.
Yes, wonderful. And do you think as well, with this same question, will there be more of a climate change focus throughout Science Mission Directorate and the science community as a whole?
So remember, the Science Mission Directorate has anything from quantum effects and on the space station all the way to understanding the beginning of the universe. So I want to tell you, the one element that is really cross-cutting is one that's focused on astrobiology, which is really about finding life elsewhere. And in that sense, looking at other planets and their evolution, whether it's in the solar system or even planets outside of the solar system within the galaxy, looking at that is a core priority, and it's one that we're really focused on. What we're learning, of course, from these other planets is also about our own. The most important part, though, especially related to applications, will be the investments we make directly in Earth science and the utility that will come from that through its applications program and beyond.
Wonderful. Those are very relevant topics. You are correct. I appreciate you taking the time to answer these questions and coming to chat with us today.
Yeah, thanks and congrats to all of you, and thanks everybody all around for being part of this important meeting and this important activity. Thanks so much, Adriana.
Yes, thank you for your continued support of the Earth Science and Applied Sciences program. So now I will hand the mic over to Dr. Emily Silat Glassman, Program Manager for the Applied Sciences program, to give a week in review.
Great. Hello, everyone. It's such a pleasure and an honor to get to share my thoughts during Earth Science Applications Week with all of you. Since I started at NASA, this has been a real highlight for me every summer, and this year is no exception, even with us being all virtual. So we heard a huge variety of content this past week, and kudos to the organizers for everything they did to set this up so seamlessly between 3 different platforms. We heard flash talks, we heard career panels. I listened to talks about projects that boost disaster readiness and projects that enhance water resource management. And in reflecting over all that I've heard over the past 4 days, I was really struck by the fact that the work that you all do really embodies the guiding principles in our new strategic plan: innovation, integrity, inclusion, and collaboration. First, on innovation, I heard a project that showed that they were using commercial high-resolution data to validate much coarser resolution satellite measurements to look at Brazil. There were a number of projects that showed the use of machine learning algorithms for crop mapping. A developed talk that showed the creation of Jupyter notebooks to enable open source science. And one of the really astounding things about that talk was that the developers doing it had no previous Python experience. And by the end of the term, they had these fully functioning Jupyter notebooks. So when I think about what this landscape looked like about 5 years ago, these examples, this was the stuff of research papers, so many of it even behind paywalls. It wasn't, these techniques, while super promising, weren't in the hands of so many of the communities that could use them. So one thing that was just thrilling to me is seeing how your projects are enabling access to the best earth science knowledge and information. And you're really bringing these cutting edge technologies out of the laboratory, out of the realms of the papers, into the hands of users. So that was really wonderful to see. On the integrity, I think that the transparency that you all showed in exploring whether the available data is the right data to answer a particular user's research questions was really wonderful to see. We often talk about that we're not just looking for the most innovative application, we're looking also for practical applications. So the openness that you bring to exploring different methods, trying different techniques, and transparency also to the limitations that you might encounter. I think all of those are really crucial to ensuring that NASA remains a trusted partner. So the third of our principles is inclusion. And we know we have a lot of work to do to make sure that our teams at all levels better represent the demographics of our society. And even more than that, we need to do more to make the space to hear all the perspectives that should be at the table. But I will say I feel such hope in hearing the voices of all of you around the country and around the globe. It was really staggering to see, the beginning of each session chime in where I saw countries that I had no idea would be coming to the table for this meeting. So hearing about some of the work that's been going on with the Navajo Nation, with NASA Harvest Africa initiatives, and the work that Servier has been doing to update their service planning toolkit to ensure that women and those in marginalized communities realize equal benefits from geospatial technologies. This is all tremendous work. So my request to all of you is please keep pushing us so that everyone can contribute to their fullest potential. And that's when we're really going to be deriving the most benefit to society. Last but not least, we have our value of collaboration, and we saw this across the board with your talks on so many dimensions: collaboration across your research teams, across NASA centers, with your partners. And I just want to say that I think it's very easy to talk about collaboration. It's much harder to do collaboration effectively, to create those trusted open partnerships where when problems arise, and they inevitably arise, you know how to work with the other folks to overcome them. I think, during a global pandemic, these collaborations and partnerships were challenged like never before. And frankly, when we began this year, I was tempering my expectations for what this program was going to be able to accomplish, knowing that so much of it is relationship building. But I shouldn't have tempered my expectations, because across the work we saw here, across the portfolio of folks that we support, you've just blown all expectations out of the water. And for that, we're so grateful. So, the work that we're doing, and Dr. Zurbuchen and Dr. Schmidt and others have alluded to this, is going to become even more pressing. As many of you saw this past week with the release of the latest report from the Intergovernmental Panel on Climate Change, unless there are deep reductions in greenhouse gas emissions over the coming decades, we're going to be seeing global warming that exceeds 1.5 to 2 degrees Celsius. And with that warming, regions are going to be seeing more impacts from climate change. So what do? I think this is where we go back to our fundamentals. And these are things that you all know how to do. We start with the decisions. Understand the decision-making context. What does someone do when they go to work? What flexibilities do they have? What choices do they make? What challenges do they face? Then we can start layering in the environmental information, the earth science context. How has their environment been in the past? What are folks experiencing now? What are the different scenarios for what they might experience in the future? So this is stuff you know, this is your bread and butter, and this is what we've been so thrilled to see over the past week. So while this work takes on greater urgency, we're not starting from scratch. We've got a lot of great work to build on from all of you. And I'll end here that what gives me real hope and is the thing that gets me out of bed and really excited to come to work every day is seeing how many of you want to contribute and make a difference. Meeting you at the networking events, reading your detailed questions in the chat, listening to your presentations, it's been inspiring. So I'll just end by saying thank you so much for joining us today. Thanks for joining us this week, and I hope you continue to find ways to work with us. Thanks.
Thank you, Dr. Silat Glassman, for that great overview. So how do we end this amazing week? Next, we want to focus on that action component Dr. Zurbuchen mentioned. We're now going to hear a couple of talks describing ways for everyone to engage and get involved using NASA data. First off, I'd like to welcome Dr. Cynthia Hall from Earth Science Data Systems, who will present on data pathfinders.
Thank you, Adriana. Am I all good? Great.
We can hear you great.
Great, thank you. Hi, everyone. My name is Cynthia Hall, and I serve as the Community Coordinator for NASA's Earth Science Data Systems program. The foundation of our program is open access for open source science. And you can go to the next slide, thank you. And that is really the open sharing of data, information, and knowledge with within the scientific and application communities, as well as the wider public, so that we can really accelerate scientific research and understanding. Next slide, please. NASA Earth Science data are freely available, and there are multiple entry points to the data promoting this open access. We have NASA Worldview, a visualization application that enables the interactive exploration of nearly 1,000 data visualizations and the ability to do image comparisons and even make short animations. We have Earth Data Search that provides searches through the entire NASA EOSDIS data collection and easy download of that requested data. And then we have individual tools from EOSDIS Distributed Active Archive Centers, or DACs, that enable a wide range of data analysis and manipulations. Still, EOSDIS data users have challenges. First, they're often confused about where to get started using NASA EOSDIS data. Also, the sheer number of possible data sets for any given measurement can be overwhelming to a novice data user. For example, there are over 8,000 data collections in Earth Data Search, and even filtering, as you see here, to one instrument, VIIRS, and one type of observation, sea surface temperature, we still return, Earth Data Search still returns 43 matching collections. Next slide. It's critical then that we provide a roadmap or a pathway to relevant data and applications for specific investigations. And NASA Data Pathfinders help do just that. Pathfinders are data product selection guides focused on science disciplines and application areas, providing information on specific and relevant measurements. They have direct links to commonly used data sets across NASA's Earth Science collections. And finally, they link to tools which provide ways of visualizing and subsetting the data with an option to save the data in various file formats. Next slide. We have pathfinders on a variety of real-world topics. Agriculture and water resources directs users to NASA datasets that can aid in forecasting future events or even responding to current events like drought. Biological diversity and ecological forecasting directs users to NASA datasets that can aid in monitoring changes in biodiversity, species distribution modeling, and conservation management. Disasters, including cyclones, earthquakes and volcanoes, extreme heat, floods, and landslides, directs users to NASA datasets that can aid in monitoring conditions that might contribute to natural disasters, measuring and mitigating risk, and assessing post-event impacts to surrounding areas. Diseases provides data on environmental conditions that can affect vector-borne disease transmission. Greenhouse gases focuses on satellite and airborne measurements of greenhouse gases such as carbon dioxide, methane, water vapor, and more. Some notable ground-based measurements of carbon dioxide are also included. Health and air quality provides data sets to monitor air quality for a particular area and then to correlate that air quality to health conditions. Sea level change provides observation data that help in our understanding of the causes and impacts of sea level rise. Sustainable Development Goals, or SDGs, provide measurements of air quality, land surface reflectance, land cover, population, and other socioeconomic data that provide metrics for tracking progress toward meeting SDG targets. Water quality helps those who are trying to determine the impacts of changes in water quality to ecosystems, humans, and the environment, and then to restore and protect coastal and surface waters. And then finally, Wildfires provides access to data sets that are critical in fire monitoring and fire management. We also have a Geographic Information System, or GIS data pathfinder, which points users to NASA's GIS-ready data sets and tools from the DACs that help transform the data into a more GIS-friendly format. With all of these, I have been working closely with NASA's Applied Sciences program areas to become more familiar with applications-based user communities, how they're using NASA data, and what their challenges and needs are with regards to remote sensing data. This information has been an integral part in producing the Pathfinders. At the ESDS program, we want to make sure we are truly reaching a broad and diverse audience. Next slide. So let's explore the various sections of the Pathfinders. Annual surveys of ESDS data users indicate that users, especially novice users, have difficulty knowing which data set to select. So to address this challenge, each Pathfinder features an About the Data section that provides information to help novice data users select data sets that might be suited for their research. So we provide the measurement taken, the satellite or platform, the instrument or sensor, and then the spatial and temporal resolution for that measurement. The Use the Data section, also a feature of every Pathfinder, provides information on how the data are currently being used for planning and decision making. It provides real-world examples of data in action. Next slide. With the Pathfinders, we have several sections providing direct links to commonly used data sets. For example, if we looked at the Disasters Pathfinder, more of an event-based theme, there may be a need for assessment of environmental conditions just prior to an event, such as precipitation, sea surface temperature, winds, sea level pressure, all of this for, say, a tropical cyclone. We have near real-time assessment data, many of those just mentioned, but often available generally 3 hours after a satellite observation. It is important to note that near real-time products have not been created using the best and available ancillary calibration and ephemeris information and should only be used when data latency is not a concern. The Pathfinders provide measurements that aid in post-event impacts like surface reflectance or synthetic aperture radar to map flood inundation, soil moisture, power outages, and so on. Other Pathfinders provide measurements that can be used in habitat suitability, for example, to understand environmental conditions that can contribute to the spread of vector-borne disease transmission or to model species distribution. Next slide. As mentioned before, the objective of the Pathfinders is not to provide links to all dataset collections for a given measurement, but rather a representative collection of data that are commonly used for a specific use case. In Earth Data Search, if you filter to just sea surface temperature, you get around 1,500 data collections. But in the Sea Level Change Pathfinder, we're only linking to the 4 major dataset collections you see on the right-hand image. Each Pathfinder is extensively reviewed by both applied science users and DAC subject matter experts to help ensure that these data sets included are indeed some of the most commonly used for any given area of study. Our expert reviewers also help ensure that the information is accurate and that the relevant tools for visualization and analysis are highlighted. Information in the Pathfinders is reviewed on a regular basis and updated to ensure that data products and links are valid and current. Next slide. The Tools for Data Access and Visualization section, also found in each Pathfinder, has a brief introduction to each tool from Earth Data Search and Worldview to relevant DAC tools like Giovanni, CDOS, and peers. The section also links to useful webinars, RSET trainings, or tutorials on using the tools. Next slide. In addition to data pathfinders, the Learn section on the Earth Data website also features data toolkits. Toolkits are designed for more experienced data users and do not include as much guidance on data sets and applications. In the Learn section, we also have backgrounders on a variety of topics, such as the basics of remote sensing, synthetic aperture radar or SAR technology, nighttime lights imagery, and more. Next slide. NASA Earth Data's wealth of data discovery and data access resources, such as the pathfinders, the toolkits, and the backgrounders, are designed to help you find, access, and use NASA Earth science data that can help in your research or your organization's decision-making process. As noted at the beginning, all NASA ESDS data and products are fully and openly available to anyone, anywhere in the world. Come explore at earthdata.nasa.gov. Thank you.
Thank you, Cindy, for showing us how to easily access NASA Earth observation data. Next, I'd like to welcome Sarah Hemmings to talk about the Space Apps Challenge.
Thank you, Adriana. Can I get a mic check, please?
We can hear and see you great.
Great. Hi, everyone. Sarah Hemmings here from the NASA Space Apps program. I'm here to talk to you about the past 10 years of Space Apps. We're celebrating our 10th annual event this year, and you can see our new 10th annual event logo here. I'd like to tell you more about how you can be involved in Space Apps and whether Space Apps might be active in a community around the world that you're associated with. Next slide, please. So this is the easiest way to describe what Space Apps is, and look at the Space Apps footprint. The NASA International Space Apps Challenge is the world's largest annual global hackathon. And now what does that mean? Well, each one of these dots on the map here, there are 250 of them. This is a location where a local lead who is a volunteer for the Space Apps program puts on their own Space Apps hackathon all in unison one weekend in October every year. And you can see here that the dots we've got across the world are spanning about 87 countries last year. And while we normally have events in person in each of these locations, last year they were actually local virtual events, all held virtually. Next slide, please. So let me back up a little bit. You might be asking yourself, what is a hackathon? Because hacking is bad, right? Well, hackathon is actually a combination of the word hack and marathon, but hack in this sense means more like exploratory computer programming, exploratory coding. So it does have its roots in cybersecurity, but hackathons like Space Apps are really more of an innovation competition where teams will participate in what's really a design sprint over about 48 hours over the weekend. And we call it a sprint, but it's really more of a marathon because I've seen teams show up with tents and sleeping bags all ready to basically work for 48 hours and take some cat naps in between. So how does it work? Well, NASA experts from across the agency issue challenge statements in Earth and space science and technology, and they link them to associated open data from NASA that the participants can use to solve the challenges. The participants use our web platform to form teams, and then over the hackathon weekend, which is October 2nd through 3rd this year, they create solutions to the challenges. NASA experts and also our partners at partner space agencies judge the solutions that are submitted, and we select winners. Next slide, please. So let me give you some highlights about Space Apps. So it actually began in 2012, but the focus then was just on space technology. However, Space Apps moved to the Earth Science Division in 2017, and with the inclusion of Earth science and technology challenges, we saw participation in Space Apps surge. We've actually engaged with over 150,000 participants to date in our past 10 events. And the goals of Space Apps are really to, at its core, raise awareness of NASA's open data, get people interested in it, get people familiar with how to access it and how to use it, and also to encourage the growth and diversity of the next generation of scientists, engineers, computer programmers, but also people from non-traditional hackathon disciplines like design, business, architecture, anything. all are welcome at Space Apps. We try to be as inclusive as possible because we believe that's how the strongest teams are formed. That's where the winning solutions are made. And lastly, of course, one of the goals of Space Apps is to foster interest in Earth and space science and technology. It's also to inspire the collaboration, the creativity, and the critical thinking that is so key to an innovation competition. Next slide, please. And I'll say, you know, while one of the goals of Space Apps is that collaboration, inevitably teams are competitive and focused on winning and on some of the prizes that are offered. And traditionally what is offered to all the winning teams is an invitation from NASA to attend a rocket launch in the United States. And that's very popular around the world. Next slide, please. I love my maps, and so I'm going to show you another one because I know you love them too. Here's what our 2020 participation looked like around the world, and you'll definitely notice some darker green spots where participation was higher. The country of India actually had the highest number of participants, while the country of Brazil actually had the highest number of individual events, with between 20 and 30 events across the country. Egypt had the largest events. Alexandria and Cairo both had approximately 1,000 participants. And then we have the United States and Turkey in the top 5 with countries with the most participants for the 2020 event. I'd also like to highlight here that when we polled all of the participants who attended our virtual event, we found that we had participants from 168 countries and territories around the world. I mean, almost every country and territory in the world. And so the reach of the event beyond those 87 countries that we have physical locations in is just astounding, and something we've learned from the past months of the pandemic is just how far reach can go when it's virtual. Next slide, please. So local leads are part of the ingredient in the Space Apps soup that's so important. Those local leads are all of those dots around the world in that map that I first showed you, where they're holding a local event where they'll put together resources to arrange their own venue, arrange sponsors, arrange food maybe, make sure there's a strong internet connection. And in a sense, they're also open data ambassadors and STEAM ambassadors around the world in those locations, because they're gathering people, gathering participants together for Space Apps, but they also tend to be associated with local hubs of innovation in those communities. And Space Apps serves to strengthen those local hubs and sort of be a yearly event that they can look forward to every year and schedule their programming around every year. The local leads are key in forming these new communities of collaboration that Space Apps has. And of course, the hackathon itself is key in creating these communities of collaboration. And Space Apps is also a professional development and networking opportunity for these local leads. And we're looking at how we can further strengthen their capacity in the locations where they are to be better open data ambassadors around the world. Something I'd just like to also mention is that we informally have learned that about 37.5% of the local leads are female, which in science and technology is a great number, and we're always working to try to improve that. If you'd like to apply to host in 2022, I'll show you in a minute how you can do that. Next slide, please. So we're not alone, as you can see, in thinking Space Apps is great, but I want to tell you one more statistic, and that is that our social media reach last year was over 71 million people around the world came in contact or engaged with the hashtag Space Apps. And that was a 29% increase over 2019. Part of that is because we put more resources into communication, but part of it was also because we held a special COVID-19 edition of Space Apps last year. And so every year we find that the social media reach is expanding, and this is part of what's driving Space Apps growth. Next slide, please. One of the innovations that we've included for the 10th annual Space Apps is that we've partnered with 10 international space agencies around the world this year. We're so excited about this. So we have the space agencies of Australia, Brazil, Paraguay, Europe, Argentina, Canada, Japan. We also have NASA, of course. Bahrain and South Africa have joined us in the Space Apps family this year to make sure that we extend the reach of the program into more communities worldwide, especially given that this program will be virtual again this year. Next slide. I'd like to show you the Space Apps website because I hope that you'll be going there soon. And if you're interested in participating as a participant in Space Apps and forming your own team and answering some of the challenges, I encourage you to go to the sign up button here in the top menu. If you go to the next slide, please. And if you're looking to see if there's a location near you where there's a local lead active in Space Apps, you can go to our map at the locations menu and do a search there to see if there's an event you can get involved with. Next slide, please. So finally, I'd like to extend another invitation to join us. Join us as a SME or as a judge, join us as a local lead, join us as a participant. You can do all of this through our website at spaceappschallenge.org. And if you'd like to propose a challenge for 2022 and you're in the agency, please get in touch with our colleague, Jessica Chow, and she can give you instructions for how to do that next year. Thank you so much.
Thank you, Sarah. What a great initiative. I hope everybody took note and is able to learn more on the website if they are wanting to participate.
Thank you.
Great. Now I'd like to pass the mic to Erin Martin and Sterling Reber to walk us through the upcoming applications guidebook.
Hi, good morning, good afternoon, and good evening to everyone out there. It's really wonderful to be with you. This has been a fantastic week, and it's really been like an open buffet for Sterling and me in terms of being able to learn more and get more experience and lessons learned for this guidebook. Let me just start out by saying it's congratulations on the 20th anniversary of the Applied Sciences program. It's a very auspicious occasion for launching this guidebook, which is an effort to synthesize and pull together some of the best practices that have emerged from this great depth of experience around applied science applications. So moving to our next slide, we would be happy to tell you a little bit more about what we're doing. The aim of this guidebook, as I was mentioning, is to synthesize best practices, but to also highlight some of the emerging practices and trends in the way that Earth observation applications are being developed. We're looking at an audience that is primarily emerging applied scientists or young scientists who are getting involved in this, perhaps also basic research scientists who are considering applied work, and also PIs new to NASA, and so they can get a little bit of exposure to the ways that NASA is working in applied science. But we do hope that even for those that have been doing applications for 5, 10, 20 years, there might still be some interesting and new things in this guide. And in fact, the format that we're using is a kind of dynamic, interactive e-learning approach, and Sterling will tell you about that in just a minute, but we're trying to make this something different. We don't want this to be your average your grandmother's guidebook. We're trying to make this something really new and different and engaging, and we'll look forward to feedback from you on whether we're achieving that or not. So far, we've started with our knowledge capture process. We've been consulting people sort of in the extended NASA family. We've talked to a lot of program managers, to PIs. We've had the opportunity to connect with some of the developed fellows, which has been great. And it's still going on because the more we learn, the more we want to learn and the more detail we want. But I'd like to say thanks to the many of you who've been involved in the process so far, either through interviews or the survey. And as I'll tell you toward the end, there's still an opportunity to engage. So we're looking to have this guide done and launched toward the end of the year, probably late November. If you want to go to my next slide, I'll just tell you a little bit about sort of the main pieces of information that are here. These are images from our prototype, by the way. And the first section is sort of broken into 4 pieces, and it gives you the opportunity to get into this guidebook and anything that interests you. You know, you don't have to start at page 1. You can jump into these different sections and see what's there, see what interests you. The first section is about success stories. There's success factors and really what it takes to develop applied sciences applications. The next section, which is in the top right corners on critical challenges, is about the applications and really looking at the many, many ways that EO data is used to drive decisions and to make a difference on a lot of important topics around the world. Delivering sustainable applications is kind of the practitioner's corner of this in many ways, where we do a deep dive on things like program management, evaluation, that really the steps of the application. So there's quite a bit of meat and potatoes, if you will, in that section for applied scientists. And then the last piece of it is the use cases, where we're looking at doing a graphic representation of some of the applications that have been done over the last few years, and not a showy overview of them, but really looking at the nuts and bolts and what happened, what were some of the key decision points, what were some of the challenges, how were they resolved, you know, highlighting important aspects of user engagement and you know, the development of impactful applications with users. So I think there's a lot there, but Sterling and I wanted to just take a moment to also share with you a little bit of how the platform is coming together. So I'll turn the microphone over to Sterling to share a little bit there.
Thanks, Erin. So when early on in this project, we knew that we wanted to create a product that was visually engaging and use different multimedia assets, as well as was easily navigable. We researched different technologies and ended up kind of landing on an e-learning authoring tool called Particulate Storyline. And there are a few reasons why we chose the Storyline versus building a website or using other web-based technologies. One of the main reasons is that it uses a lot less resource. There's a lot less resources involved to produce the guidebook. For example, there's little to no coding required to create engaging and interactive content. Therefore, it's also more cost effective, and it's also fully customizable. So it's easy to align with NASA's graphic and accessibility standards. And then once we kind of narrowed down on Storyline, we wanted to leverage the features that it offers. And I think one of the key features is that Storyline allows the ability for users to create their own paths. And we really like this idea because, you know, for example, we could develop a case study where we use 2 different example applications, and they ended up using different project management approaches, for example. And we could then develop a module where users can make their own decisions on how they would approach this scenario. So, you know, some might go in one direction, others might go in another direction, and we can all kind of learn through those scenarios. It's also very kind of interactivity is the key feature of Storyline. We can create rollover images and quizzes and embed multimedia assets such as videos and sound bites, which we've done quite extensively through this project, as well as link externally to other sites. And then I think finally the published product that is the last, what is used in the end is a fast loading HTML5 package file that is easy to upload to a web server. And it's also fully responsive. So it looks great on all devices such as tablets and mobile phones and laptops. So that's back to you, Erin, I think.
Great, thanks, Sterling. Yeah, just to underscore there that our hope was really to strike a balance between something that would be much easier to put together than a website, but still have a lot of the power of the internet and in an online platform and the dynamism that would come with that. So we're really excited about this technology. But a really important point to make in this presentation is that this activity is not really just about the guidebook. The guidebook is the launch pad for what we hope will be a longer term engagement in looking at applied sciences, bringing people together around the best practices and thinking about potentially doing symposia once or twice a year that would bring people together to share experiences, and just really capitalizing on this wealth of experience and these lessons and bringing people together to share, which is something we've heard from the PIs over and over again is a huge benefit of collaborating with NASA. So we're very excited about this opportunity. In my last slide, I just wanted to give the audience a chance to hear how they might participate. We're mid-process, as I mentioned. We have a very rough first draft, but we are still looking for content. We're looking for ideas about, a best practice that you would love to share. If you had the opportunity to sit down with somebody coming into applied science, what would be that one lesson learned you'd share? We're also going to be doing beta testing probably in early September, early to mid-September, and we would love for people to volunteer to be part of that beta testing. So if you're interested in participating and in any way, we would love to have you involved. Please, there's my email, drop me a line and we can figure out what the next steps would be. But it's a great opportunity to be working with all of you. A shout out to the work group that's been helping us, which is Sarah Brennan, Cindy Schmidt, Lauren Childs-Gleason, and of course, Tony Kim. So many thanks. We'll look forward to collaborating with you and sharing this again a little bit later in the year. Back to you, Adriana.
Wonderful. Thank you, Erin and Sterling. This guidebook will be a great addition to the Applied Sciences Toolkit. I'd like to welcome back Applied Sciences Director Lawrence Friedl for some closing remarks.
Great, thanks, Adriana. And I guess, when I look back at the week, really, really impressed with the sense of service. It's really, really inspiring. Your commitment is also really sort of inspiring. And I would say that the community of people who are looking at this science in action, I would say it's in really, really good hands. And I'm also just really sort of heartened about the community that we have. It's such a rich one to be part of. And also, while I recognize that a lot of the focus this week was on the Applied Sciences program and our work, I'm really glad that we could also, bring together and include people and programs from across all of NASA Earth Science, as well as data from a range of different organizations beyond NASA, because it really is a global effort to do these Earth Science applications activities. We really need lots of different collaborations. Earlier, I really liked Thomas's comments, and I noted that he used the word congratulate. So he congratulated you all on your work. It was congratulations on choosing this rewarding work to help benefit society. And it was also congratulations on all the achievements that you've had in doing that. And so really, really echo his remarks. And also Emily earlier, she mentioned ways that the talks and the events this week really touched on the principles of our new strategic plan: innovation, inclusion, collaboration, and integrity. And I couldn't agree more with her. So when I look back in the week, there's so many different memorable moments and elements of creativity. Just a few that really sort of stood out to me, and by no means, by no means is this exhaustive. I really liked ecological forecasting and their use of their video testimonials. I thought it was a great touch to add into their presentations. John Bolton, in his relay race metaphor, I thought it was so apt. Quote of the week for me was from Bad Dorn, like, NASA has been doing agriculture as long as it's been doing astronauts. Hadn't heard that one before if he's used it, so that was a great one. I had a chance to listen in on the career panel on Tuesday, and the people there had so much wisdom that it's worth a listen if you didn't get a chance to participate or attend that. There's also the use of story maps and the Health and Air Quality Applied Sciences team. That video with all the voices and faces of that team was just a really rich sort of addition to things. So really appreciate the sort of multimedia approach that people took. And so if this week, the Earth Science Applications Week, if it sort of showed where we're at, really, I kind of want to talk about a little bit of where we're going. And so with the President's budget request for 2022, it's got some new themes in it for Earth Science applications. A big one that serves lots of attention is on wildfires. And trying to restart our program that we've had years ago related to wildfires. There's so much stuff from Earth Science that relates to and connects up to support wildfires and all the organizations, public and private, that are dealing with that. Obviously, other themes are climate and helping organizations be more resilient to the climate risks, and also helping to sort of see how can NASA and all the Earth Science information, how do we help contribute to improving environmental justice and improving equity in the nation and also more broadly. But I think particularly to starting with here domestically. So that's the president's request. I would say with the new strategy that we released on Monday, a big thing of where we're going is more with the private sector, and that means companies, nonprofits, and foundations. And the latter follows a broader trend that we've been tracking, and this is the support of science by philanthropic organizations and foundations. And in some cases, those philanthropies are taking on more the roles that traditionally have been by government. And so we are looking at some key partnership opportunities with some philanthropies and some of these foundations. So it's really something we've been pursuing and look to pursue more. Another trend that we're tracking is the sort of trend around alternative science, alternative facts in some cases, but particularly we're focused on the alternative science that seems to be out there. A risk that we see is this erosion of trust in science and in science-based decision making. And I would say that makes it all the more important for the work that we're doing in Earth Science applications. So our work, I think, is all the more important here. In terms of countering that alternative science. Our work and sort of showing the connections between science and decision making, between science and people's lives, and what it means, I think, is all the more critical, so we can sort of help restore that trust in science. And I think what we need to be doing is sort of showing the positive value of scientific information when it comes to people's livelihoods or the economy or the quality of life. Now, I would say aligned with this hard work of doing applications, as we've seen throughout the week, I know it's been, the work to accomplish what's been talked about this week was quite involved and quite extensive, as much as people made it sound easy. Though there is a lot of hard work involved there, but I also want to encourage us to remember that we need to be sharing information about it. Really, our work isn't done until it's communicated. And so I want to remind everyone to develop their communication skills. I want to remind everyone to keep broadening awareness about Earth Science applications. Now, I fully recognize that a lot of people, we talk about, people aren't always aware that NASA does Earth Science. And I guess I wanted to sort of say, look, let's not be disappointed that people may not know that NASA does it. Let's use this surprising element as an asset. So, if people aren't aware that NASA does Earth Science, or that you can use assets from space to support decision-making here on Earth, use that as an asset. Use that to pitch something to media to get to that surprising element. Use it to reach new audiences. And I would say for people in develop or early career people who are out there listening, like, use it as a way to set yourself apart. And so, yeah, so really use that. So looking back at Earth Science Applications Week early this morning, I told you that we had over 1,000 people register from over 60 countries. We had over 70 talks, and we had over 100 speakers related to that. We had 3 panels across the week. And I really, really want to give a shout out to the speakers, the panelists, and the MCs. So right now we're showing all the ones that are at our different plenary sessions across the 4 days. Really, a great job to everyone, as well as, and here's this slide is sort of showing the different symposium sessions, both the speakers and the MCs. Really, really our deep appreciation. Now we know that these things don't happen. This week didn't happen by itself, and so many thanks, as it says, many thanks to our planning committee. It was led by the 4 people that were shown. Obviously, our thanks are going out to everyone, but really, a special thanks and a special appreciation to Sydney, Amanda, Lauren, and Jonathan. Just so grateful for everything you did, and personally for everything you did to help me stay informed of what was going on. And so as we're wrapping up this session, we can go to the next slide. I want to remind you, it's not quite the end of the week. So the top of the hour is not quite the end of the week. We are having that Develop Community Social, and that's going to begin right afterwards. And so I'll see some of you there. But in closing, I want to just sort of say, obviously, a major item for us this week has been the Earth Science Applications Week. But I would say another item that's occurring this week is the Perseid Meteor Shower. This is the annual event that has lots of different shooting stars. Something that's what my family has really been focusing on. And in many ways, they're sort of connected. You know, in many ways, I see the Earth Science Applications Week a lot like these shooting stars. They're eye-opening, they're dazzling, and they're over before you know it. And so thank you very much for a great Earth Science Applications Week 2021. Thanks for everything that you're doing to put Earth science into action. Keep doing these inspiring things. We'll see you next year. Back to you, Adriana.
Thank you, Lawrence, for those wonderful closing remarks. And thanks again to today's presenters for sharing all the different ways that we can get started using NASA data for different applications. To our audience, I'd like to remind everyone that all talks this week have been recorded and will be uploaded to the Earth Science Applications website next week. Make sure to go check them out once they're uploaded. Like Lauren said, I'd also like to invite everyone to the Develop Community Social starting now on the Wonder platform, where you can network with some of this week's speakers, as well as alumni, partners, and friends of the Develop program. Thanks again to everyone who joined us for Earth Science Applications Week. Whether you joined for an hour or for multiple days, we hope you learned something new this week.